All right. Yep. Hello, it's Keith from Kinvert. Gonna do some more live coding. So this time what I want to do is get these sorted so that the rows start off as 0, 1, 2, 3, 4, 5, and then they sort to the columns of 0, 1, 2, 3, 4, 5, etc. So that every different number will blend to every other different number. And then along the diagonal, they should just remain the same throughout. So we'll see how it goes. Again, this is another live coding, so you're just going to be seeing it raw, and you're going to see all the mistakes and everything, and there will probably be plenty. So what I already did is I looked through and found the indexes of numbers that I like, and so I've already got that. It was kind of boring, but this took me like 15 minutes or something. So we're basically just, I'm still recording you, taking in the values, or I'm making a list of lists basically. And so this is like all the zeros, yeah, all the zeros. This is all the ones here, on and on and on. And this is because I wasn't finding a good 8. For some reason I just couldn't really find an 8 that I liked, so once I update this, you know, there was this one, but it wasn't closed at the top. But this one's pretty good. So it was between that one and this one, and anyway, I spent a little longer. I went all the way up to 495. But yeah, so I'll probably end up moving this up, and then I guess I'll change this, or should I just do another that's sorted? I'll do a sorted grid. So this will be sorted grid vid, and here we'll be doing the same as this, and then I'll just be modifying this here, and then get a little space. Okay, so encoder preds, encoder array, xtest. Okay, so that was like a temporary way of doing it. Now I'm going to go to 500. Total frames of 100, tiles of 10 will remain, and then this is where we're getting the grid of latent spaces. And so we're going to end up doing this a different way. So basically, let's first make my list. Okay, so the indexes, I guess, is 183, 37, 147, 51, 48. I remember that must have been the 4. Yeah, it was. 165, 131, 64, 495, the outlier, and 16. Alright, so this is our indexes. And so now I could make the latent spaces is empty for IDX in the indexes, and then we're going to get each latent space. So this latent space, latent grid append, well, this will, okay. How, okay, there's the extra. So this latent space is encoder preds, and this will be encoder preds IDX. Next latent space, oh crap. So I'm not going to be doing the next latent space yet. And then this diff, I'm not going to be doing the diff yet. And then I'm just going to append. So the latent spaces dot append this latent space. And let me just to keep the variable naming kind of the same here. Latent spaces. This latent space is that. I'm not doing anything special to this. I'm not normalizing. Yeah, this isn't being displayed. It's the output of the decoder that needs to be made to make OpenCV happy. Yeah, 5.5 minutes. Okay, so this should get us all the latent spaces, and then I ought to be able to okay, so this is where I'm making the actual new latent spaces. So pred's index, I don't think I need this. This latent space is so this latent space is going to be I, and then next latent space is going to be J. I wonder if this is going to work. This diff is that divided by total frames. Remember, I screwed that up last time. Latent grid dot append this latent space, this diff. Okay, that should take care of it. And then we'll see. I mean, I should just run it and see what happens. I have a feeling it's not going to work, but who knows till you try. Okay, and then what I'm going to want to do is, so I called it blends, so I'm going to be doing plt.imshow blends, and it should be going by the frames it is, and so 0 should be my starting point before any of the blending is done. Ooh, I might have, this is probably still wrong. I think these are going to be wrong. So we might be wasting a bit of time here. While this is running, so let's go over this again. So I just make a list of all the values. This is going to be a list of lists, and I'm basically just saying I haven't found any yet. And for these values, right, because you know, I is going to be the first time it goes through 0, then 1, then 2, and we're just using that and making sure that we are matching I with that Y label. And then we're saying, hey, we did find one, and we're going to append the index that we're at to this, and then we get this list of indexes for Y. So this whole list is all of the zeros. Well, not all the zeros, but 20 or 40 of them, 20 of them. So we're grabbing 20 of the 0. Oh, this is done, isn't it? 90 is as high as it goes. Okay, this is probably wrong. I mean, that's not as bad as I thought it would be. And then 99. Okay, I mean, that's not as bad as I thought. Okay, so pred's index new. This latent space, I believe that this will be I. No. Oh boy. So I've got the latent space and the diff. Shit, how's this gonna work? This latent space. So this latent space for the 0 is gonna be the 0. Right, the top left, I want to be a 0 instead of, I mean, in the end, it did the right thing, just in the wrong order. So I don't think I need pred's index. This decoder, and then we've got an I and a J. Okay, so for the first one, okay, right here, we want this latent space to be the 0, 0. Okay, we just want this to be a 0. And here it will be, okay? So we got 0, latent grid, latent grid, latent grid, dot append. So latent grid, we're getting 100 latent grid, but do I really? Yeah, I do need 100 of those. I do need 100 of those. Oh, so I do need I need a pres index? I times tiles plus j. Maybe that was right, because this is not like a square. Okay, this is just a long list, and so shit. Why am I getting a 7? Okay, so 4 IDX and indexes. So the first should be a 0. Okay, latent spaces. 183 was a 0, right? Okay, and then, yeah, I looked up here. This latent space is encoder preds, which is this, encoder np x test 0 to 500. So it's keeping the same indexes. IDX, which is 183, numpy. The latent spaces append this latent space. Good. Okay. Ooh. Okay. This latent space is the latent spaces. The latent spaces. And then maybe this stays the same. Okay, that might have been the cause, and unfortunately, that's going to take another numpy array has no attribute numpy. Well, that's a heck of a thing. So this latent space is the latent spaces, yeah. I don't know what's wrong with calling like dog.dog. You know, it's already a dog. It should just work. But anyway, so let's see. This is the old one, right? And I was just taking one image, and then whatever's next in the xtest index is what I'm blending to. So this was just, you know, by random. The numbers are uglier, like you see this 5 and different stuff. That's a pretty good 5. It's a good 4. But pretty good 0. That's a good 0. But yeah, so it was just blending. This one's going to become a 1. This one's going to become a 0. This one's going to become a 4. And I'd rather have the grid where every number is blending to every other number. And so that's what I'm trying to do here. This is almost done. It only goes to 90 for the prints anyway. And then we'll be able to show the image, show if it's starting at all 0s, 1s, 2s, 3s, and then if it ends at all 0s, 1s, 2s, 3s. All right, so it's not quite done. Now it's done. Perfect. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Go to 99. Boom. Okay, so this is what I wanted. Now I'm going to try to make the video. Is this the only step I need? Sorted. Got the image. Grid blend. 5. I don't need that anymore. Sorted. And then MP4, that 4 I blend, blends. Color blend, jet map. Okay. This I think is quick. Yeah, so let's see how that went. Grid blend sorted. Cross your fingers. Last night, by the way, I actually got like 6 hours of sleep. So that's makes a big difference. Okay, so 0, yep, so these ones you see along the diagonal are, in fact, staying the same. This should become a 9, and it is. This 9 should become a 0, and it is, yep. So every number is blending to every other number. All right, So that was 15 minutes. Yeah, I don't know what to do now that it worked so easy. That went pretty well. Yeah, this 3 goes through a bit of a goofy change, but it looks good at the beginning and end, and it works. What else looks kind of weird? I specifically chose a 7 with the line in the middle because I thought it'd be a little harder instead of the ones that are just the 2 segments or whatever. And then I chose some that are thick and some that are thin to have a bit of variety, so you can see the 1 when it becomes the 4, like you can see the thickness increase, you know. So I wanted some thin and thick ones, and but yeah. And then I think since the last video, I did a couple more runs to get the because when I was doing the fuzzy stuff, I really didn't care if the images were blurry. Well, not blurry, but if I had high mean squared error, it doesn't necessarily correlate with blurriness, but the output of my autoencoder might not be accurately reflecting the X test coming in. And so I reduced the mean square error here by just training it some more, and I got the test data down to 0.008, which is pretty good. And then obviously, you know, these were lower. Now the validation loss didn't necessarily have to be lower, but it was. But yeah, definitely the training data should have a lower mean squared error. And let's see, I don't remember if I went over this, but I found that with the batch norms, I'd be getting like negative numbers and stuff, which is hard to convert to OpenCV, where they want a 0 to a 255. So I ended up adding in these ReLU max value ones, and it made it harder to train, but it ended up with easier results to at least convert to 0 to 255 uint8s, which I'm doing somewhere in here. Yes. So I'm getting, you know, do the decoder. I just straight up do the decoder on whatever the latent space is, except I'm making sure it's shaped properly, okay? And then it kind of has an extra set of brackets around it. I don't exactly know why. And so I've got the extra 0 here. It's probably something like, it's probably like a 28 by 28 by 1 or something like, I don't know that, okay? And so that's why I have to take the 0 so that I'm left with the 28 by 28. Again, don't take my word for that, but that's my current guess for what happened there. All I know is that I did a little trial and error and it worked, and I think I'm literally copying code from when I was half, what's a polite word? Anyway, I was sleep deprived, and my son is still sick, but last night I actually got to sleep. And so yeah, then we're multiplying by 255 to take those values that are between 0 and 1, scale them up, and then we're converting it to a uint8 because that's what OpenCV wants. We don't want like float values that are 254.837, you know. And then we're just setting that chunk of blends. So blends is just, you know, the total number of frames, and then we're making the tiles, you know, 28 times tiles by 28 times tiles, and then by 1 because it's single channel. And this actually could be what's causing this. I don't know for sure, but well, actually, no, I think it would be, because this doesn't have like an extra 0 or anything like that. But anyway, yep, so we're setting it equal to this image, and then this is just where we're printing it. And again, this is the end result because this is the 99th frame, this is the 0th frame, and so that's why it looks like this. So you're literally just making a grid, and then you just kind of transpose that, and you're just blending between that transpose. And so you're getting each conceivable latent space blending to each other conceivable latent space. And yeah, this worked first guess here. The only problem was, I think what was I using the old encoder preds here instead of the way that I re-put this into these latent space list. And yeah, this is how I was finding which numbers I wanted to pluck. And then again, the result is right here. and I'll let that play a little bit longer. But yeah, this one went a lot better. I actually got to sleep, so. But yeah, I'm going to keep making more stuff kind of similar to this. I'm just trying to learn more machine learning and, get in a bit of time each day. And I was already coding a lot every day, and now I'm coding, getting paid for it. But yeah, I still want to be able to practice stuff and keep up on top of things and learn new things. I'm not really learning how to do this. I mean, this is kind of easy, but I don't want to get rusty on it. Just keep doing this kind of thing. So yeah, whenever I can, I'll try to do these live coding things. Again, I don't have time to edit videos and stuff like I used to, so basically you're just going to get some raw things when I'm doing a practice session, or maybe I'll make something, not record me live coding it, but then later go over what I made. But we'll see. If you think of any other stuff that you want to see me do related to autoencoders, let me know. One of them that might be on my list, I've done some things where I basically from scratch made some stuff. So resume, CV, MNIST from scratch, MNIST. So in this one, I made MNIST from scratch. So I literally and I'm just using NumPy. So like add noise, I could be using like Kira's layer, the Gaussian noise. Nope, I'm making it on my own, right? I could be doing rotation. Nope, I'm doing it on my own. And so all these different augmentations I coded manually. Making the layers and stuff, I coded it manually. This one I did with classes. And so and this that's another thing that I could do in the future, is make my own it's not going to be as good as TensorFlow or PyTorch or anything, but I could make my own neural network system from scratch. So that'd be a fun one. Right now I only have like dense layers, but you could add like convolutions and this and that. But here's the class, and it's just taking in the number of rows and columns, because now you're not just giving like a size. You've got to make sure that you can do your matrix multiplication. And so yeah, ideally I would make this easier for the user so you don't have to put in sizes that can multiply, because that's a little bit of a pain. But there's the forward pass and the backward pass. So anyway, the main point is that I built this doing machine learning from scratch. I don't even think the batching worked. I don't think I got it to do batch. I think I had to keep the batch at 1 or at a break. But yeah, maybe I could do this and do an autoencoder based on something I build from scratch like this. That could be another one. But yeah, again, just let me know if there's specific stuff you guys want to see me do, and I'll see if I can do it. Again, my free time is very limited, but we'll see. Anyway, rambling again too long, I'll go back to the results. Here's what we did. It took approximately 15 minutes to do it, if I recall. And yeah, pretty happy with it. I made a few mistakes, but this time I wasn't sleep deprived, so I was actually able to kind of figure it out instead of bumbling around. Okay, so hope you guys enjoyed it. Hope it was helpful. Keith from Kinvert, and I will see you guys later. Bye-bye.